expressions quadratic in form. In this video, we'll recognize expressions that are quadratic in form, make a substitution and factor the expression, and then rewrite it in terms of the original variable. We say an expression is quadratic in form if we can make a substitution of u for some expression in x to turn it into something that's quadratic. For example, if u is the square root of x, and I fill in the square root of x in this template, it simplifies to x plus 3 root x minus 10. Now, that's not quadratic, but it is quadratic in form because if I write it in terms of u, it says u squared plus 3u minus 10. If u is 1 over x, we have 1 over x squared plus 3 over x minus 10. Not a quadratic, but quadratic in form. Well, we want to factor completely x to the fourth plus 7x squared minus 8. It looks like it might be quadratic in form, so let's see if we can figure out what u is. The best way to do that is to look at the middle term. That would be a plain u, so 7x squared, what if u was x squared? Well, let's try it. If u is x squared, how much is u squared? Well, it's x squared squared, so it's x to the fourth. And hey, that is what we have in the beginning. It's u squared. And so when I rewrite that in terms of u, it says u squared plus 7u minus 8. And I can factor that. It's quadratic. It factors to u plus 8 times u minus 1. But I can't leave it like that. The original expression was in x, so I rewrite it. U is equal to x squared. So this says x squared plus 8 and x squared minus 1. Well, now we're back to x, but we're not quite done factoring because x squared minus 1 is a difference of squares. It factors to x plus 1 times x minus 1. So x squared plus 8 not factorable further, and we have 3 binomials multiplied to give us our original expression. Let's see if we can factor 2 over x to the 6th minus 1 over x cubed minus 15. I have an x6, well, it's really a negative 6 power, and an x negative 3 in descending order, and we end in a constant, so it looks like it might be quadratic in form. And the middle term here would be what we would choose for u. So if u is 1 over x third, then u squared would be 1 over x third squared, or 1 over x6. We do have an x6 in the first term, so if we factor that 2 in front of it, we could write it as 2 times 1 over x6 minus 1 over x third, which we've decided is u, and minus 15. So rewriting in terms of u looks like 2u squared minus u minus 15. Well, if I want to factor that quadratic, I need to split the middle term. A times c, 2 times 15, is 30, and it's a negative 30. And it comes from adding 5u and subtracting 6u. And it factors u times 2u plus 5 minus 3 times 2u plus 5. And that means it's u minus 3 times 2u plus 5. Well, now all we need to do is go back to x. Since u equal 1 over x cubed, the factorization u minus 3 is 1 over x cubed minus 3, and 2u plus 5 is 2 over x cubed minus 5. So we factored the original expression, and we don't need to go any further than that. That looks good to me. X plus 5 times the square root of x plus 4 is quadratic in form. U is the square root of x. It's really helpful to look at the middle term first, and then if u is the square root of x, u squared must be the square root of x squared, or x. So I rewrite this u squared plus 5u plus 4 and factor. It factors to u plus 1, u plus 4, and now I just rewrite it. U is equal to the square root of x, and so these factors are the square root of x plus 1 and the square root of x plus 4. And so we factored the original expression. I want to compare these two expressions. They both start with an x to the fourth term. The first one says x to the fourth plus 3x squared minus 10. The last term is a constant term, and the exponents are going in descending order. Now if I look at the second one, it's x fourth plus 3x third minus 10x squared. The last term is not constant, but the exponents are in descending order. The first one is quadratic in form. U is x squared, and u squared is x fourth. But the second one, if I mistakenly think that u is x third, u squared is x sixth. And so it's not x fourth. And in fact, we don't have a constant at the end either. So what happens with this expression is that we need to factor out x squared. Then we'll have x squared times x squared plus 3x minus 10. In other words, we'll have a regular quadratic in x. So be careful when you're looking for things quadratic in form. Be sure to check what u is and what u squared is, and make sure there's not something you can factor out of every term.